morning, class. Welcome to the ninth lecture video of ME263 Machine Elements. So in this video, I will be discussing gears, focusing mainly on the terminologies and its concepts. So let's get started. So gear, one of a set of toothed wheels that work together to alter the relation between the speed of a driving mechanism and the speed of the driven parts. So as you can see here, we have various types of a gear, no? And then if we have a gear mating, we always have the driving gear and the driven gear. So nakadepende lagi yung speed ng ating driven gear dun sa ating driving gear. So first, let's discuss the types of gear. Per gear, so you can see here at the image, they are toothed wheel with radially arranged teeth parallel to the shaft axis. So ibig sabihin, the tooth arrangement natin or the geometry is parallel to the shaft axis. So ito yung shaft natin, dito natin nilalagay yung shafting, and its axis is parallel to the teeth edge. So they are used to transmit motion and power from one axis to another parallel shaft. So kapag nag-coconnect ka ng two parallel shaft, ang karaniwan na ginagamit natin sa kanila is spar gear. As you can see here, the shaft of this driving gear is parallel to the shaft of the driven gear. Next, let's talk about internal gear. Internal gear is a gear with its tip cut in the internal surface of a cylinder and meshes with spar gears. So, technically, internal gear is considered as an example or as a special kind of spar gear because by definition, spar gear has a teeth geometry cutted parallel to the shaft axis, which is in this case yung internal gear, ganun din. The only difference between the two is that the driven gear in internal gears have a teeth cut or in geometry inside a cylinder, kagaya nito. So, yung usual natin na pinion is atypical spar gear. Ang tawag naman natin dun sa gear or yung driven gear natin is ring gear usually. Next, let's talk about helical gear. Helical gears are one type of cylindrical gears with slanted tooth trace. So compared to spar gears, they have a larger contact ratio and excel in quietness and less vibration and able to transmit large force. So kaya siya nakakapag-transmit ng large force because of the tooth geometry. So compared dun sa spar gear natin, the tooth geometry natin or the tooth axis natin is not parallel to the axis natin of the shaft. Kasi nakaslant siya, no? That is also the reason kung bakit nga siya quiet and less vibration. So, lagi siyang nakakontakt dun sa gear natin. Next, let's talk about cross-helical gear. So, cross-helical gear sets are used to transmit power and motion between non-intersecting and non-parallel axes. So, it is a type of helical gear kasi 'di ba ang definition natin ng helical gear, the tooth is slanted, no? So basically, the tooth construction of the cross helical gear is the same din ng helical gear. The only difference between the two is that cross helical gear connects two non-parallel axes or two non-parallel shaftings. So si helical gear naman, slanted teeth din, construction, but the shaft connection niya is parallel. So both of the gears that mesh with each other are involute helical gears. Helical gears pa rin sila. Next, let's talk about herringbone gear. Herringbone gear is a special type of gear that is a side-to-side combination of two helical gears of opposite hands. As you can see, we have two sets of helical gear here. Ang difference lang sa helical gear natin is magkaiba sila ng slanting position. For instance, in this part, we have a left hand slanting position of a helical gear, and then the other one has a right hand slanting position. So from the top, each helical groove of this gear looks like the V, and many together form a herringbone pattern. So kaya siya tinawag na herringbone pattern because of the geometry formed between those two opposite hand helical gears. So the purpose of this type of gear is of course to increase more loading capabilities. 'Di ba? From spar gear nga, ginawa mo siyang helical gear to improve the loading capacity, and in order to improve also the loading capacity of helical gear, ginawa mo siyang alternating helical gear which is called herringbone gear. Next, let's talk about bevel gear. So bevel gear are gears where the axes of the two shafts intersect and the tooth bearing faces are the gears themselves are conically shaped. So you can see here, our gear, hindi na siya cylindrical, no? Medyo conical na siya. So, they are most often mounted on shafts that are 90 degrees apart but can be designed to work at other angles as well. So, meaning the axis natin forms a 90 degrees or other degrees other than 180 degree, because usually yung mga parallel axis natin, ang connection yan is 180 degrees, and if you want to connect non-parallel axis of shafting, pwede tayong gumamit ng bevel gear. Next, rack and pinion. Rack pinion. So gear racks are utilized to convert the rotating movement into linear motion. As you can see here, gear rack yung tawag natin dito sa linear gear natin. And a gear rack has a straight teeth cut into one surface of a square or round section of a rod and operates with pinion, which is mold cylindrical gear meshing with the gear rack. So the construction of our pinion is typical spar gear, and its teeth should be fitted to the teeth construction of our rack. So kapag umikot tong pinion, the rack motion natin or the gear rack motion natin will have a linear motion. So usually nakikita natin yan sa steering mechanisms. Next, worm gear. A worm gear is a gear consisting of a shaft with a spiral thread that engages with and drives a toothed wheel. So as you can see here, we have a threaded shaft, para siyang tinatawag natin the worm gear itself, and then we have a cylindrical toothed wheel here. So as you can see, the tooth construction or the tooth geometry of our toothed wheel has a different construction compared dun sa ating or sa other cylindrical gears. So the geometry of this kind of wheel should match our worm gear. So itong shaft natin with spiral thread, siya yung usually driving gears natin. And the driven gear natin is itong cylindrical gear natin. Pero may mga ibang application wherein nagkakabaligtad sila, wherein the cylindrical gear ang pinaka-pinion natin, then ang output motion natin will become this shaft natin. The axis of rotation of this shaft is perpendicular with the axis of this uh, cylindrical toothed wheel. So worm gears are usually used when large speed reductions are needed. So kapag ang application mo is large speed reduction but high torque application, ginagamit natin tong worm gears. Next, and last type of gear is hypoid gear. Si hypoid gear, if you look at it, is almost similar in construction to bevel gear. So it is a bevel wheel with teeth engaging with a spiral pinion mounted at uh, right angles to the wheel's axis. So yung isang visible difference between a bevel gear and a hypoid gear is the tooth construction. Yung tooth construction natin in hypoid gear is slanted or spiral compared to the straight cut dun sa ating bevel gear. So ginagamit natin siya to connect non-intersecting shafts in vehicle transmissions and other mechanism. So, pag sinabing vehicle transmission, usually makikita mo siya doon sa differential part. Next, let's talk about spar gear nomenclature. So, ito yung mga parts ng isang spar gear. And dito tayo magpo-focus sa spar gear because ang common type of gear is spar gear. First, let's talk about face width. Face width, it is the width of the tooth along the axis of the shaft. So you can see here, ito yung axis of the shaft natin, ito yung ating tooth. So ito ang ating face width. Next, space width. Ang space width naman is the circumferential distance between or along the pitch circle between two adjacent teeth. So ito yung adjacent teeth natin. The distance between them or the circumferential distance between them is called space width. Next, pitch point. Pitch point is the point of contact of a pair of gears in mesh where the angular velocity ratio is determined. So kapag nagdo-drawing tayo ng schematic diagram, 'di ba hindi dinodrawing yung mismong gear ng ating uh, or the mismong teeth ng ating gear. So ang representation natin sa kanya is in terms of a wheel. So the diameter of the wheel is dependent on the uh, diameter of the pitch point or the pitch circle. So yung point of contact niya kapag nag-draw ka ng imaginary circle, that is called the pitch point. Next, pitch circle. Pitch circle is the trajectory gained by rotating the pitch point around the respective rotary axis of gears. So ito yan. So if we mesh two gears, so the connection or a point of connection of those pitch circle is coined or called as the pitch point kagaya ng discuss ko kanina. So next, the top land. The top land is the individual tip surface of the gear. Face, it is the tooth surface between the pitch circle, yung pitch circle natin, and then the top land. Flank, it is the tooth surface between the pitch circle and the bottom land. So we have this pitch circle and this is the bottom land. Fillet. So fillet is the surface between the flank and the bottom land. Bottom land. So in the tooth groove, the part between the two fillets is called the bottom land. Usually, nilalagyan talaga natin ng fillet ang ating gear to avoid further friction kasi baka tumama yung tooth profile natin dun sa unwanted part ng ating gear. Addendum is the radial height of the tooth above the pitch circle. So from this pitch circle up to the upper part of our top land, that is addendum. The addendum, on the other hand, it is the radial height between the pitch circle and the bottom land. Working depth, so the radians or the radial distance of the engagement of mating gears. So it is the sum of the addendum of mating gear. So the addendum of a driven gear plus the addendum of the driving gear, that is called the working depth. Next, clearance. Clearance is the distance in which the addendum exceeds the addendum. So ito yung part na yan. So it is used to prevent the end of one gear from contacting the bottom of the mating gear. So by operation kasi, may times na yung gear construction natin or the upper part ng ating gear might scratch or contact the bottom part of the mated gear. So baka ukain niya, no? So ang purpose ng clearance is para meron kang safe space para hindi siya mag-contact. Next, we have tooth thickness. So the tooth thickness is the width of the gear tooth measured along the pitch circle. Circular pitch, or PC, is the distance measured along the pitch circle from a point of one tooth to another corresponding adjacent tooth. So it is also described by this equation. The circular pitch is equal to pi multiplied by the pitch diameter divided by the number of tooth. Next, diametral pitch, or PD, it is defined as the ratio of number of teeth per inch of pitch diameter. So our equation for that is PD is equals to the number of teeth divided by the pitch diameter. And the unit that we should put on the pitch diameter should be in English, specifically in terms of inches. So in calculating PD, so it has a relation when it multiplies to PC, it will be equal to pi. Next, we have the module. Module is the ratio between the pitch diameter in mm, the number of teeth. All mating gear has the same module. So kapag hindi tugma yung module ng isang gear, it will not match to the other gears natin. So it is defined mathematically by the pitch diameter in SI units, specifically in mm, divided by T, or the number of tooth. So it is also calculated using this equation. M is equals to 25.4 divided by PD. So the 25.4 came from the converting of units, no? Kasi from inches yung kanina, it is converted to mm. Kaya meron tayong 25.4 dyan. Next, let's talk about backlash. So you can see here. So the backlash is the space created between the tooth surface of corresponding mating gears. So just like clearance, it is designed in order for the gear to have a safe space para hindi mag-scratch or intensive scratch yung ano natin, yung gear surface. Kasi kapag wala kang space or the backlash, may chance na mag-stack up and it creates damage to the tooth profile. Next, for the center to center distance, so if you can see here, so it is an example, this image is an example of external spar gear. Yung ngipin niya nasa labas, no? So it is calculated using or by adding the diameter of the driven gear and the driving gear divided by 2. So in calculating the center to center distance naman ng internal gear, as kagaya nito, Internal gear is kapag nasa loob ang ngipin. So it is calculated by subtracting the diameter of the driving gear to the diameter of the driven gear. So it is also divided by 2. So fundamental law of gearing. So it states that for a pair of gear to transmit angular velocity ratio, the tooth profiles of the mating gears must be designed in such a way that the common normal line passes through a fixed point, such as this. So the normal line, this, kapag umikot yung dalawang mating gear natin, dapat pumunta siya doon or mag-match siya doon sa certain point, fixed point natin. So, kada ikot ng ngipin natin, dapat constant yun doon sa point ng dumadaan. In order for us to visualize, as you can see here, this is an involute gear, no? So, it satisfies the fundamental law of gearing. Every time na nagkakaroon ng contact ang ating gear, or the tooth of our gear, sa iisang point lang siya tumatama along dun sa normal axis natin. So in involute gear design, contact between a pair of gear teeth occurs at a single instantaneous point where two involutes of the same spiral hand meet. So as you can see here, so it satisfies the fundamental law of gearing. So that will be the end of the lecture. If you have any question, you can message me on my messenger or email. Thank you.
Fire.
Emi, faculty, yeah. Emi, faculty, yeah. Emi, faculty, yeah. Emi, faculty. Siya naman si Sir Ivan Espinosa, dulo ng pangalan. Pangako di mahihirapan at hindi kanya iiwan.